Okay, so I have here an example. Okay, suppose we are given with a beam with this section. So given an mga dimension and beam, and ginpapabiling ha aton, we are to compute for the flexural stresses in the concrete steel for beams using the transform area method. Okay, duduhit aton reinforcement. May kita reinforcement at the top, may kita reinforcement at the bottom. Ang ginpapabiling an iya tagsa-tagsa nga stress. Yan. So tulot at ginbibiling. Ang stress didi an extreme fiber in compression, ang stress didi hini nga duduha nga bar, ini nga duduha nga bar in compression also. And of course, the stress and bar in tension. So tutuloy atong ginbibiling. Yan. Okay, so paano man natin ini solve? So clearly doubly reinforced in here. Okay, so any nga type of problem is actually an investigation because you already have there the design of the beam, the dimension of the beam, and you are to evaluate the capacity. 'Di ba? An iya stress, an iya makakaya nga stress asat ginpapabiling. Compute the flexural stress. Okay, so to do this, una naton nga bubuhaton is of course to locate the neutral axis. 'Di ba amot na natong unang ginbubuhat didton ako mga assignment hayo. You have to get the distance of the neutral axis from the bottom fiber or the distance of the neutral axis from the uppermost fiber. Basta it importante malocate nimo it neutral axis. That's the most important. Okay, so how do we do that? How do we locate the neutral axis? Take note nga transformed area method na aton gagamiton. So ibig sabihin ang tanan nga steel dida, both the steel in compression and the steel in tension are now transformed into its equivalent area in concrete. Okay? So to do that, to locate the neutral axis, you have then to find the equivalent area of steel in concrete. Given naman an iya modular ratio. Okay, so dili lang kita it steel in tension. Tension. Di ba it still in tension, it pagko-compute natin it equivalent area, we just multiply the area of the steel by n, by the modular ratio, NAS, di ba? And this is equal to your n is 8 multiplied by your AS. Di ba? Your AS. So what's your area of steel in tension? That is upat daw nga number 29. Ano ito nga number 29 adit koan? So bali nga number 29, it's here. Number 29, iton diameter is 28.7 or the equivalent area is 645 mm squared. Okay, number 29. So number 29 man hiya, it's here number 29. It's here number 29. So the equivalent area is 645 mm. Yan. Equivalent area na dayon na akong ginbutang. Wala na ako pag pi over 4 multiplied by d squared. Diretso na ini area. So what's the value of NAS?
20,640 millimeter, sir.
20,640 and this is in mm raised to 2. So this is your NAS. Okay. And sunod naman, the equivalent area of steel in compression. So the equivalent area of steel in compression, that would be, okay, nayakan din nayakan. In compression nga ni daw, because of the effect of creep, i-search na lang niyo kung ano yung nga creep. Instead nga, i-multiply natin ang area of steel by n, aton i-multiply ha iya is n up 2n. 2n multiplied by ES. Nakuha? 2n multiplied by ES. But before we solve for 2n times ES prime lanay. Take note with the prime ha. Pag may dangan niyo kitaon nga prime, it's to denote nga in compression. Waray nga ni prime like this one, waray niya prime. Ibig sabihin in tension. Okay? So it ES lang natin i-solve. Before kita mag-solvehan 2n ES, before natin kuhaon ang equivalent area in concrete. In fact, pati tiya didi, ay lanin natin i-multiply hain na good. An ES lang ay na good. So, ilan nato i-multiply ha 8. So, this will be pira. An AS lanay. This is 645 times 4. 2580, is that right?
Yes, sir.
2580 Okay, an area in yan still ha. And diri pa ginko convert to concrete. How about the AS prime? This is duha nga number 25. Number 25 it iya area adi. Number 25 it iya area is 510. So we'll multiply it by 510. 2 times 510. This is equal to 1020. Is that right? Squared. So this is your value for AS prime. The area of steel in compression. So ini, AS and AS prime. Next natin nga bubuhaton. Sunod ni mga bubuhaton is, i-construct natin ang iya kuan, ang iya figure, ang iya cracked section. How do we do that? Di ba, di nala natin i-construct. Okay, so ba, ini amin niya an original figure. This one right here. That's the original figure. I-construct natin dida an iya cracked section. Okay. Project ko nga di. And the centroid, it's here. This is the centroid. And say, for example, ano din it neutral axis. And this is the neutral axis. So, ano din an block of concrete in compression. Tas may da niya buho dida, 'di ba? Kay iton dida nga buho, ano ito ang gino-occupy han steel, 'di ba? So iton nga buho, wara hiton dida concrete. It na-occupy hiton dida nga buho an steel. Okay? Then adi naman haubos ang equivalent area han steel in concrete, this is equal to NAS, 'di ba? NAS. Of course, hindi din nga buho gino-occupyhan still may da niya butang ko plus calicula didi for the purpose of discussion. May da niya didi amo niya ang 2n multiplied by ES prime. Nakuha? Ini dinhi amo niya ang concrete in compression. Ini naman niya amo niya ang steel in compression. Ang concrete may da niya buho dida. Kay iton dida nga buho na-occupy iton dida ang steel. Tapos ang steel naman imo igin convert into its equivalent concrete by multiplying it by twice of the modular ratio, 2n. Okay, that's why you have here 2n ES prime. Now, for simplicity, para mas madalit pagsosolve, para dire-diretso pagsosolve, instead nga multiply ini by 2n, an area hini nga buho which is AS prime, 'di ba? AS prime an area hiton. Kaya amo may naging occupy kung still in compression. Magfi-fill in kita dida, makuha kita didi. So mafi-fill in dida, tas dinhi may da ka man gin fill in ngadto, maiban ka dinhi hin AS prime. That's why ini nga quantity is actually equal to 2n minus 1 multiplied by ES prime. Gin-factor out ko lang ES prime. So, maida nimo 2n minus 1 ES prime. Tapos dinhi, this is b times x because this distance is x man, di ba? And this one, this is b. b times x, ang iya area. As did ang iya area is 2n minus 1 ES. As adiha ubos, ang iya area is n times ES. Yan. So, amin niya imo working kuan. Amin imo working figure. Okay? So, ito niya. So, we will then solve for the distance. Ini nga x. Isa-solve natin ito value at x. Ilulocate natin ang niya neutral axis. So, how do we do that? Of course, you will use the q above that is equal to the q below. Okay? So, this is ini amo inhiya dinhi, amo inhiya ang q above, tas adi ang area naman below. Okay? So, that's how you do that. Okay, so Q above is equal to Q below. Okay, so your Q above here, ini ang kanang concrete, that is, the area is, your base is 400. It's right here, 400 mm. So you have here 400 mm multiplied by the height. It's here. Di ba? Ini nga height. That is X. So you have here X. multiplied by the distance of the neutral axis from the centroid of this block. This is your centroid is right here, and the distance of this centroid nga di is x over 2. So you have here x over 2. Yan, meron mo x over 2 here. So that's for the block. Plus, okay, and adi naman, ini. The area, which is, what's the area? 2n. What's the value of n? What's the, adi man? Here, that's the value of n. And that is equal to 8. So we'll have here 8 minus 1. Aditakin ko compute ha, this one. Multiplied by AS prime. Ang naton AS prime is 1020. Yan, 1020. Ginsurat ko didi. Naton AS prime is 1020. Ginsolve ito naton kangina. Multiplied by the distance. The distance of this area to the neutral axis. And that distance is, ini ba nga distance? Di kandidat ira centroid nga di. Pero ba ito niya? Of course, that is, if this is x, di ba, this is x, di candidi, that is your x. So, to get this distance, x minus the distance from the centroid, tikan dinhi nga dihabaw-baw, and that is 70. Adaman, 70, adaman. So, put here x minus 70. Okay, so this is your QA. This is equal to your Q below. Ano naman, NAS. Your N is 8 and your AS is equal to 2,580. 2,580 multiplied by the distance of this area, from the neutral axis, and that is the effective depth minus x. Diba? Ini kasi nga distance, di kan di nga dida, that's the effective depth. So, minus mo 1 x, amin yung nga distance. Ini. So, that is effective depth minus x. So, your effective depth is 560. It's here. Nakikita niyo, 560 plus 70. That's your effective depth. So, I'll put here 560 plus 70. Ima-minus mo an x. Yan. Yan. So, if you solve for the value of x, what's the value of x here? Let me use your calculator. So solving for the value of x, your x will be equal to 190. So my answer here is 190.228. So I'll put here 190.228 mm. Okay, so in my calculator, I'll just store my 190.228 to letter A. So in-store ko lang para later. Okay, after solving for the value of x, now maaram na kita kung ano distance, mga distances. Let me redraw this one. I-redraw ko lang ha, para mas klaro. This is your neutral axis. Ano din yan imo block of the concrete in compression. Tas ada dida an imo equivalent concrete of steel. This one, this is your 2n minus 1 ES prime. Yan. Tas adi naman didi ubos an imo equivalent concrete of steel in tension. This is NES. Yan. So, ini nga distance na determine na naton, this is your x, and that is 190.228. Oh, pero man ini nga distance. Effective depth, 560 plus 70 minus x. So, your value for this distance is 439.77. Yan. How about the distance? Ini ba nga distance? Di kandida nga di. Ano ito niya nga distance? X minus d prime. And by the way ngayon, we denote this, ini nga distance, ini nga 70. The distance of the centroid of the steel reinforcement in compression to the uppermost fiber, ini nga distance. We denote it as d prime. D prime. So to solve this distance from the centroid of the steel in compression to the neutral axis, we just need to subtract yung 190.228 by d prime. And your d prime is 70. So this will be, this is 120.228. So I guess ano man naintindihan niyo kung din ini nga mga distances? Naintindihan ba kung
Yes,
din ini nga mga distances?
Yes, sir. Yes, sir.
Okay, sige, nice. Okay, so we need to know those distances because we will now solve for the value of the moment of inertia of the crack section, an ICR. So we'll solve for the value of ICR. Okay. With respect, of course, to the neutral axis. This is your neutral axis. Okay. So unahon taan yan nga block ini and block of the concrete in compression. So your dimension for that block, let me take a look at the dimensions, and that is 400 yung width and your x is 190. Okay, so this is 400, this distance. Diba? 400 yan. Okay, so we have here 400 base times BH cube over 3, diba? BH cube over 3. So your base is 400. Adit atong ko consider this one. This one. Init atong ko consider. Yan. Base is 400. H, your H is your X, 190.228. 190.228. So we have here 190.228. That's the area. Cube, BH cube over 12 man. Over 3, I mean. BH cube over 3. Over 3. Yan. Plus, next is, ano yan naman? Yan naman, ini naman, ini. Yan, plus, ano ba ito niya? 2n minus 1, your n is 8 minus 1, diba? 2n, ano man? 2n minus 1 multiplied by ES prime. Your ES prime, na-solve natin kanina and it was found out to be 1020. 1020 multiplied by, this is, diba, AD squared. Your A is this one and your D squared is an ADDD. Okay, so your D is, what's your D? Ada naman, 120.228. That's the distance of that area from the neutral axis. Okay, so we have here 120.228 squared plus, ano naman nga area? This area right here. Okay, and that is equal to NES. Your N is 8. And your ES intention, that is 2580. 2580 multiplied by the distance of the centroid of this block to the neutral axis, and that is, ano man, 439.771. 439.771. Don't forget to square that value. Okay, AD squared ito niya. Yan. So your value for ICR will be, pera ba? What's the value for ICR? Five one three zero 73327. Okay, let me store
Okay,
that
sir.
value to letter B. I'll put it here. This is, ano to? I-dictate daw nga how? 5130 733327.
73327.
Yan
Yes,
siya na?
sir.
Yan. So this is in mm raised to 4. O may nakita ICR. Ang ato naman sunod nga ibubuhaton, amo na i-compute ang EA stresses. From the formula FB, that is equal to my over I. Ang mga flexural stresses ang aton ko-compute. Okay, so our formula now, ang aton flexural stress and concrete. What's that sound? Mr. Nagsishave ka. I'm sorry. Okay, FC, this is the flexural stress of the concrete, of the concrete in compression. So your FC is equal to your moment, naghatag an problem in moment, is here 275 kilonewton meter. So we have to convert that to Newton mm. So we have here 275 times 10 raised to 6 para maging Newton mm, an aton kilonewton meter. So, yung convert natin into Newton mm. Multiplied by your y, take note the distance of the fiber you are considering to the neutral axis. That's the value of y. So, here, natin yung consider din is the concrete extreme fiber of the concrete in compression. And this is anyan din di ba? And that's the distance of that fiber from the neutral axis is we have already solved that, and that is the value of x, di ba? X man, di man. The distance of this fiber from the neutral axis is x, sira man, nakabutang x. And we already have solved for the value of x, and that is 190.228. 190.228. So it's here 190.228 all over your moment of inertia, and that is ICR. That is 5130
Delay.
7333327. What's the value of your FC? 10.20. Is that right?
Yes,
10.20. This is in megapascal. That is 10.20 megapascal. May da kasi di answer. And we are correct. Your FC is 10.20 megapascal. Now let's solve for Fs prime. Fs prime, take note ha, may dida prime. Ibig sabihin, ang ito niyan, stress of the steel in compression because of that prime. Ito nga, dito baw-baw. So, atong isa-solve din now is your Fs prime. Ibig sabihin in compression. This is equal to same lang how it atong formula my over I. So your moment is 275 times 10 raised to 6 multiplied by the distance. Take note, still in compression. Adit aton still in compression ini. That distance, the centroid of this area to the neutral axis is 120.228. Nasolve na natin, 120.228. So I'll put here 120.228 all over your ICR, that is 5130 So your value for Fs prime is pera.
6.44.
Pera?
6.44.
6.44 ay may da pa ako hingalimtan. And aton Fs ngayon, di ba, convert naton and steel into concrete. So you have to divide this by n pa. Oh no, 2n. Kaya ano, and in compression, di ba, twice, gimultiply natin hiyahin 2n. Di ba? Gimultiply natin hiyahin 2n. So you have to divide the Fs pa by 2n. Or, instead of dividing this by 2n, multiply na lang natin ang yanhi nga dididi by 2n. Di ba? Fs, instead nga i-divide in 2n
Yes.
din ang 2n, i-multiply na lang natin nga dito. So may da pa natin, i-multiply natin in 2n pa. Pira?
103.11.
Pira?
103.11.
0.11. This is in megapascal. Let me check our answer. 103.10 megapascal. So, wrong ka. Charot. Joke lang. 100, and aton answer didi, and ang answer is 103.10. And aton answer is 103.11. So, buti lang nga discrepancy that could be neglected. Pwede na ito hiyang answer. Bangin kasi ang aton pag round off din hi. So this is our answer, Fs. That's the flexural stress of steel in compression, 103.11 megapascal. Next is the stress naman of the steel in tension. Same lang ako, pareho lang ako ito niya, Fs. Waray na prime to denote tension. So we have here 275 times 10 raised to 6. That's your magnitude of the moment in Newton mm. This is multiplied by, pero ba distance to? Di man? The distance of this area here, in yung area, to the neutral axis is 439.771. 439.771. So, 439.771. Yan. 439.77. All over, of course, the moment of inertia. 5130733327. And of course, you have to multiply this by n pa. Kaya ano, ang Fs, imoging convert into its equivalent concrete. Diba? So, dapat niya over n. Instead of over n, i-multiply ko na lang n dito. Okay, so what's the value for Fs?
188.57.
This is 188.57. This is in megapascal. Let me check. 188.57. The answer here is 188.56. So, okay. So, indeed, our answer is correct. Your Fs is equal to 188.57. So, ano yan mga stresses? 10.20 for the concrete. Of course, the extreme fiber in compression ini, 10.20 megapascal. And of course, your Fs, the stress of the steel in compression, and the stress of the steel in tension, 188.57. Naka-English system here. This is in English system. So, let us try to convert everything into metric. Wari kasi di ko wari ko sample problem in metric system. Okay, before we start, let us try to convert everything lanay into metric. Okay, so ibutang ko dili dayon. Your FC is equal to 12,000 12.41. This is in megapascal. Take note, FC is the allowable stress of the concrete in compression. Kung di rin given, ang pagkuha hini nga FC, that is 0.45 FC prime. Okay, and of course, your Fs is equal to Fs prime. What's the difference between Fs and Fs prime? It Fs, amo niya ang steel reinforcement didto in tension. The steel reinforcement in tension, and Fs prime, may danganit prime, pero may hiya ang reinforcement in compression. So, double reinforce kita. According to this problem, that is equal to 24,000 psi, or in megapascal, that is 165.47. Your N is 8. 12 inches is 305. This is 305 mm. 2 inches, 50.8 or 51 na lang. 51. Your 2 inches is 51 mm. So, Didi is 102 mm. 16. This is 406 mm. And your 10. So, this is 254 mm. Nakikita niyo yung dimension? I hope
Yes,
nakikita.
sir.
Okay, so
Yes,
your
sir.
4, this is 102 mm. Okay, yan. So, nakakuha na kita. Number 10. Ano it number 10? Ano it diameter hit ko ang number 10? Adi. Didi ko gimbutang. Number 10 nga number nga diameter of bar, that is 9.5 millimeter. 9.5 millimeter. To 9.5 millimeter diameter. Amit hit yada. Okay, so ang ipapabiling aton is the allowable resisting moment of the section shown using the transformed area. So, ibig sabihin, i-drawing natin ang iya sinisiring transform area or the transform crack section. Okay. Ano to? Ang una, of course, before anything else, let us try to solve laanay an AS prime. What is AS prime? That's the area of the steel in compression. AS prime, di ba? It's right here. So, usa daw nga number 10. Number 10, the diameter of number 10 bar is 9.5 mm. So, masahin la. This will be pi over 4 multiplied by 9.5 mm squared. Pero man ini.
141.76438685. 141.76 po, sir.
Uh,
Mm
are,
squared.
are you sure?
Yes. And what's sir?
3.88. 70.88, sir.
70.74.
70.88, I think.
Relax.
0.88 mm squared.
Okay, sir, sorry, multiply ko na by 2.
Squared, ha? 70.88 mm squared. So, ang 9.5 mm squared, yeah. Siya, baging multiply mo yung 2 and 9.5. Anyways. Okay. So, your ES is 70.88. Okay, sunod, isosolve natin ang valuehan AS naman. AS prime man ini. This is AS prime. So, natin isosolve ang AS. So, in tension naman. Pero an kuan, daman, duduha man, nakabutang. Duduha daw nga 9.5 mm diameter. So, that would be 2 multiplied by pi over 4, the area of circle, multiplied by 9.5 mm squared. So this is AS. Your AS therefore is equal to, pero your answer,
Yes,
141.76.
sir.
Yan, mm squared. Yan. Okay, so may na nakita AS prime, may na nakita AS. Sunod, okay, bubutang ko dito ha. This is your neutral axis. Okay. This is your neutral axis. Of course, okay ha? Dili kasi kita maaram kung hainit neutral axis. Pamati ha, this is very important. Dili kita maaram kung hainit neutral axis, bangin aanit neutral axis, or bangin gihap aadididihan flange. Di ba? Dili kita maaram. So you have to be very careful. It una laan ay, i-assume naton nga aada hiya hit web. Okay? I-assume naton nga aada hiya hit web. Okay, so kung aada hiya hit web, it imo area di habaw-baw hit neutral axis na sugad. Yan. Okay, may daman ano kuan, may daman reinforcement. Di man nakikita niyo yung reinforcement usa daw nga number 10. Ibutan ko na laha ang transform section na indayon. Amon hiyan equivalent area of the steel in concrete. Tapos didi naman may danimuan equivalent area han steel in concrete in tension. Yan. Okay, anya di kanan kuan ini ha, steel in compression, ali naman this is steel in tension. Okay. So anyan hi nga in compression, dili na kita hit kuan, dili na hit tension. This is equal to NAS. Okay, NAS siya. Ano ali naman nga usa, this is equal to 2N minus 1 multiplied by AS prime. Okay? 2N minus 1 multiplied by AS prime. Okay, yan. And imo naman x, your x of course is ang distance from the extreme fiber of the compression block to the neutral axis. Amon yan ang imo x. So ini nga distance nga dili iya centroid, that is naghatag ba ang total an effective depth? Naghatag, right? Adaman. 102 plus 406 plus 2 inches. Your 2 inches is equal to 51 mm. So that would be 406 plus 102. Tikan ba didi? Tikan ba didi? Tikan didi nga didi. Nga da. Makikita? So that is 102 plus 406 plus 2 inches, or that is equal to 51 mm. So peran effective depth. 102 plus 406 plus 51, that is 559. Okay? So ang imo effective depth is 559. So this will be 559 minus x. Yan, ini nga distance. Ini nga distance, that is 559 minus x. Okay. So, adi pa nga yan. How about this distance? Ini, tikan tida nga dihit neutral axis. Okay. Pero ba? Kita adi nyo didi. From the neutral axis, that would be x minus 51 mm. Yan. So, this is x. Kay x man tikan dinhi, x tikan dinhi nga didi, x hiya. So, ima-minus ko laan yan hinga distance, makukuha ko na yan hinga distance, tikan dinhi nga di. So, x minus, this will be x minus 2 inches. It's right here, 2 inches or 51 mm minus 51. Yan. So, meron na kita. Try to solve for the value of of x, I mean. So, to do that, Q above daw should be equal to Q below. Okay, so your Q above is, what's the value of N pala? N is 8. Adaman, N is 8. Okay, so 8. Mas maganda. Adilaan ita kukuha na, inilaan yung area. That would be 2 times 8, N is 8, minus 1, multiplied by ES prime. Nasolve na natin ang ES prime. Adi man, 70.88. This is 70.88. Yan. Area pala itong hiya. 2n minus 1 AS prime. An area pala itong hiya. An iya pa distance from the neutral axis. Okay, moment area man, di ba? That this is x minus 51. Okay, plus. Okay, may da pa man ano. May da pa man an kanan yadi, an kanan concrete compression block ini. Okay? So, it akon pagkuan hini, it akon pag-divide, isa-subdivide ko hiya pasugad para mas madali. Okay, adilaanay, inilanay nga area, and web laanay. So that would be, what's the width of the web? The width of the web is 102. It's right here. 102 multiplied by x. Diba? 102 ini dinhi, tapos ang iya height na matikan didi nga ddd is x. Ano man? X. Yan. So that's the area. Times the distance from the centroid nga didihit neutral axis, that is x over 2. Yan. Plus, again, kaya ano may plus, adi pa, an kuan, an kanan didi, ini. Ngayon, adi didi. Pero ito niya. Pero it area niya. It area hini, plus it area hini, with laanay, iya, aniya with laanay. So, pera. The width of the flange is 305. Okay ha, ini. It ato naging kukuha ini nga width plus adi nga width. And to do that, kukuhaon lanay naton ang total width and flange, just imaminus naton ang width and web para makuha naton ini nga distance. Okay, so that would be pero ba ang width and flange? 300 305 305. So this is 305 minus the width of the web, and that is 102. 102 multiplied by, of course, and height yan ini, the thickness of the flange, and that is 102. Adi man, the thickness of the flange here is 102 or 4 inches. Okay. 102. An area pala ini. Multiplied pa ang distance ti candidate center dito nga area nga neutral axis. Take note the centroid of both of this area is somewhere here. Kuto nga diha neutral axis. And that is x. Kaya x minus 102 over 2. Kaya 102 over 2? Kahit i-centroid kasi ada dahit katungahit 102. Naintindihan pa ba niyo? Sana naintindihan pa niyo, ha? Please tell me kung medyo nalilipungan. Okay. Inihiya nga 305 minus 102. Let me try to explain that first. Diba, nasugad. Ang aton flange. Nasugad. Gingamit na naman ang ini nga portion. Diba? Gingamit na ini nga portion. Kung nabibili nila ini. Diba? Gingamit na naman adi nga portion. Nabibili nila yada nga unshaded. Okay. So ini daw, ini nga distance di kandidi, this is pera ba to? 305. 305. Yan. Tapos ini naman nga distance, this is the thickness of the, the width of the web, that is 102. So para ma-determine natin ang inila, tapos ini ba? Iniging kaliko didi. Okay. Oh. It iya width. Pwede ko kasi pag pag kung ano nala, 'di ba, pwede ko hira pag nakukulan ako pag-explain. Pwede ko hira pag, um, dugtungon nala, masugad ba? Okay, gindugtong ko nala hira and this is 305 minus 102. Tas imo-multiply ko anya di, which is also 102, makukuha ko na ang areahan yan hi. Aamoy ni at yadi nga 305 minus 102 times 102. Sana naintindihan niyo. Anya ni ba an combined area na yan hi, ang unshaded part tapos anyan hi. Ang combined area na ito niya, ito nga 205 minus 102 times 102. But you still have to multiply that by its distance from the neutral axis because moment area man, di ba? Q is the moment area. Okay, so i-multiply mo pa, tikan hiton dida it centroid nera di ba? Ada dida, di ba? Somewhere here to the neutral axis. Adi man itira centroid, ada man itira centroid din hi to the neutral axis and that is x kasi tikan didi extreme fiber in compression nga neutral axis is x. Tas ima-minus mo ang katungahan 102 which is 51. So this will be x minus 51. Yan. Okay. So tapos nakitahan q above. This is now equal to q below. Masama ulit q below kaya da man la. So this will be your n is equal to 8 and as adi man takin bulat gin kukuan ha bubutang didi. 8 times your as is 141.76. This is 141.76. Yan. Multiply by its distance from the neutral axis and that is 559 minus x. Oh, one equation, one unknown, masosolve ni mo it x. Quadratic formula na naman ito. Paano man i-quadratic? Igual na, i-simplify, simplify everything. Then you use quadratic formula to solve for the value of x. But I will not do it na ha. Basta i-solve ko na let value it x. So this is
66.35. 66.35097.
wala kita problema. This is 66.35. This is in mm. Would you accept this answer, Mr. John J? 66.35. 66.35 gyapon na ako nakuha. Now, itakon pa kay Ana. Would you accept this value of x? Yes or no? Ano, Mr. Rovic?
sir.
Kay ano?
Kaya natin gin assume nga na neutral axis adi hawid.
Pero,
Pero ito nga 66.35 ato ha lunch.
very good. Nakuha niyo? Nag-assume kita nga nato neutral axis ada ha web. May da kita problema kay ano nato nakuha nga x is only 66.35 and that will tell you nga no, the neutral axis is not on the web but on the flange, di ba? Marasite solution. Oh, imo i-redo everything. You will redo everything. Tikan di dahiton nga QA is equal to QB. Oh, kakadi naton ha. Kakadi ko didi. So this is the neutral axis. Tapos ayan web. I mean flange. Ano ba yan? Okay, tapos aadi didi haubos an imo equivalent concrete of the reinforcement. Still reinforcement in tension. Tapos somewhere here, aada didaan equivalent concrete of the steel reinforcement in compression. Take note, diri hiabot nga ha. Kita balik kita nga di. Balik kita nga. Dili kita focus it dili nga flange. Imo daw neutral axis, aanhi dinhi, di ba? Aanhi dinhi. Basta ada daw with flange. So an imo centroid, an imo centroid, an imo reinforcing bar in compression is not diri hiya dahit but nga hini. Bakit kasi nimo ikada didit but nga, di ba diri aadi hiya didit ubos. So dapat i-consider mo gihapon ito. Bakit ka magsayupit imo pag-solution. Yan. So that's why diri ada hiya centroid. Okay? So this is now your value for x. And ini, this is 559 minus x. Tapos, ini nga distance, dili ko nalibutang, that is x minus 51. Kaya ano x minus 51? Diba, x man ini. O, an iya centroid han steel reinforcement in compression is located at 2 inches from the extreme fiber, or that is 51 mm. That's why, ang akong imutang di is x minus 51. Yan. Yan ha? Tapos, imo nga babalikon. QA should be equal to, this is equal to QB. Okay, so your Q above, pero ato ang width han flange, the width of the flange is 305. So this is 305 multiplied by x times x over 2. Okay, tas ang kanan equivalent concrete of the steel in compression, that is plus, what's the value of n? N is 8, right? 8 ba? Yes, 8. Minus 1, 2n minus 1 multiplied by ES prime, that is 70.88. Multiplied by the distance, x minus 51. Yan. So this is equal to NAS, your N is 8, your AS is 141.76 multiplied by 559 minus x. Yan. Amo yung working equation. Now, please solve for the value of x.
60.36.
60.36. This is in mm. So, your x is 60.36. O, may ka na x. 60.36. Pero man ini nga distance. Ini. 559 minus x.
498.64.
Mm. Oh, kuha dayon an moment of inertia. Moment of inertia of the crack section. So, an imo ICR. This is equal to, an babawalaan ay. This is 305 multiplied by 60.36 cubed over 3 plus your 2n, your n is 8 minus 1. 2n minus 1 multiplied by ES prime, that is 70.88. Yan, di ba? 70.88 multiplied by its distance is x minus, pero an x? 60.36 minus 51. Yan, 60.36 minus 51 squared, di ba? AD squared ba ya, di ba? Ang atong ginukuhaan, AD squared. So, your A is here, di ba? Ang imo A is 2n minus 1 multiplied by ES prime, tas ang imo D squared is this one. May dapan niya squared. And of course, add naman haubos. Yan he. That is NAS, or 8 multiplied by your AS is 141.76 multiplied by 559 or 498 na lang. Ano naman ngayon? Solve na ngayon. Di man 498.64. This is 498.64 squared ha. AD squared kasi. So what's your value for ICR?
3044,30551.74.
This one?
Yes, sir.
3044 30551.74.
Yun yung-
Please
Next.
iba paki-recheck ha bangin may sayop. 3044 3055 1.74. Okay, that's your value for ICR. After finding for the value of the ICR, take note ang ipapabiling ha aton is kuan daw the moment capacity. 'Di ba? Ang moment capacity ang ipapabiling ha aton. Okay, so duduhaan iya material. So unahon lang natin for concrete lang anay. Okay, so you are solving for the value of the moment. So from the general flexural formula, FB is equal to my over I. So rearrange the equation. Honestly, amo agin susugad ko lang hindi because dili ko talaga memorize ang formulahan moment. FBI over Y. Yan. So this is our working equation. So your moment for concrete iniha, your FB, naghatag ba yung FB? I think naghatag an allowable concrete, allowable allowable bending stress for concrete. It's right here, di ba? FC is 12.41 megapascal. So we'll use that one, 12.41. So adi, may net naton 12.41. I'll put it here, 12.41. This is in megapascal multiplied by your I. We already have solved for the value of I, and that is 3044. 3044, 3055, 1.75 mm raised to 4. All over, what's your value for I, for Y? Of course, that is 60.36. 60.36 mm. Oh, what's the value of M?
6259
625.
90840.
Yan. 62590840.
0.74.
0.74. Okay, this is in
Newton.
Newton mm. So your moment, this is 62.59. This is in kilonewton meter. Yan. So this is your moment. Okay? According to concrete. According to concrete. Now, take note, duha an iyo material. So, according to concrete, ibig sabihin kung I mean, if the concrete will prevail, the capacity of the beam will be 62.59 kilonewton meter. How about if the steel and steel reinforcement will prevail? For steel, okay, same lang how your moment is equal to FB multiplied by I over Y. Oh, nagkatagyap yan FB, the allowable bending stress of steel. It's right here, naman. 165.47 megapascal. Duduha ba yan imo steel, di ba? May compression, may intention. Unahon taan steel in tension lanay. Okay, an FS lanay, an FS. So that is 165.47. So unahon taan still in tension. Okay, so an aton FB 165.47. Now, before kita ko man hindi hingakuan. Let me erase this first. Diba natin general formula, FB is equal to My over I. Pero kay we are using steel man, tiknutan natin steel, convert natin into concrete. So you still have to divide this by N. Intention lang na kita ha. Tension kita, tension. Okay. 'Di ba amo niya naton formula for steel in tension. Kay gin-divide na pa naton hin N because at aton steel gin-convert naton into its equivalent concrete using the modular ratio. So you still have to divide the FB by N. So rearranging this equation and you are solving for the value of M, you will get M is equal to FB times I over NY. Yan. So this will be your working equation. Okay. So your FB, naghatag in FB daw, that is 165.47. Yan. This is in megapascal, of course. Multiplied by I. Ano to natin I? Ano man? 30, 44, 30, 55, 1.74 mm raised to 4. All over. Okay, so your N, di ba natin N is 8 multiplied by Y. And Y nimo is the distance from the neutral axis to the centroid of the steel in tension. That is 498.64. 498.64. 498.64 mm. Yan. So your M is equal to
126 27878.
126
27878.
78. What na point?
0.68.
Mm,
Yun.
right? Or this will be 12.628 kilonewton meter. Is that right?
Yes, sir.
Yes. So this is your moment. The moment if the steel will prevail ha, the steel in tension. 12.628 daw it moment. Oh, may pa natin usa nga steel ha. For steel naman, this is in compression. Take note na natin formula again. FB is equal to My over I. But since this is in compression naton, ang aton FB, di-divide natin instead nga N, i-divide natin into N. Kaya compression hiya. Nakuha? Sana
Yes,
nakuha.
sir.
So your moment, therefore, rearranging this equation, you will get FB multiplied by I over 2NY. Yan. So your FB, same lang ha, 165.47 multiplied by all over 2 times 8 times, ano't imo Y? Kita nga diyan aton figure. Ano't imo Y?
X minus 50.
51. Okay, X minus 51. Very good. Your X, pero to an X. My goodness, mabalik na naman. X is 60.36. 60.36 minus 51. Yan. So your moment now will be, pera,
336365.
come again?
336365.
336365.
674.
Ano to? Sorry. 336, 375?
36365. 336365. 674.39 Newton M.
Newton mm. So your moment therefore is 336.366 kilonewton meter. Meter yan ha, hindi yan M. Meter. Yan. Okay. So this is for steel in compression. I-zoom out ko ha. Nakikita pa ba gihap? Bisan i-zoom out ko.
Gutian na po, sir. Medyo gutian na, sir.
Okay.
Okay na, sir.
Okay, sige. An aton, if the concrete will prevail, the value of the moment is 62.59 kilonewton meter. This is for concrete, 62.59. Now, if the steel in tension will prevail, the value of the moment is 12.628 kilonewton meter. If the steel in compression will prevail, the value of the moment will be 336.366 kilonewton meter. Now, out of these three, ang ipapabiling kasi is the moment capacity of the whole section of the concrete beam, reinforced concrete beam. Tutuluan imo nakuha nga moment. Hay man iti mo i-answer. Imo i-answer, of course,
Anguti, sir.
Anguti, yes. 12.628 kilonewton meter. Amo iti mo answer because um, if your moment will reach 12.628 kilonewton meter, safe pahiyahan still in tension, safe pahiyahan still in compression, safe pahiya didihan concrete. Di ba? Pero kung adi natin pilion, so umabot nga niya 62.59 kilonewton meter, di rin na niya safe for the steel in tension. Magfi-fail lag gihapan imo ko. Take note, if one material will fail, all of your the whole section an imo reinforced concrete beam will fail, di ba? Nakan daw it imo design daw it imo structure is as strong as its weakest member. Your structure is as strong as its weakest member. Yun. So that's how you solve. Um, before I dismiss you, do you have any question? May ba niyo pakiana?
Maray
May
na,
da
sir.
waray na. Sige. Okay, please open your camera. I want to see your beautiful and handsome faces. Char. Char. Ano na, wait lang. Naanit pag gallery hini. Okay. Please open your camera. Ay na, let's wait for the others. Nagluluding pa iba diri pa naka-open era camera. Okay. Wait lang. There are over 50 in this meeting. Please open your camera because I need this in my accomplishment report. Okay na? Ginihinuyam hi. Okay, please open your camera. Okay, ma-print screen ako ha. Thank you. Okay, thank you, thank you. Thank you. If you don't
Thank you,
have
sir.
any question now, you are dismissed. Thank you for listening. I hope you learned something in this in
Sir, and
this
video, sir.
Thank you, sir.
um
Yes,
Yes,
sir.
class.
sir.
Okay.
Thank
Thank
you,
you,
sir.
sir.
Thank you, sir.
Sige.
Thank you, sir.